The AP Chemistry exam is in 37 days. Let's start our review. We're going to begin with Unit 1, and today I'm going to talk about topics 1.1 through 1.4. Unit 1 is atomic structure and properties, and it is 7 to 9% of the exam. Let's dive right in. Topic 1.1 is moles and molar mass. We would think of this as mole conversions. Molar mass is determined by using the periodic table. So for example, to calculate the molar mass of magnesium nitrate, you do 1 times the molar mass of magnesium, which is 24.31, plus 2 times the molar mass of nitrogen, because that 2 distributes in, 14.01, plus 6, because that 2 distributes to the 3, times the molar mass of oxygen, which is more or less 16. Sum those together and you get 148.33 grams per moles. To convert from grams to moles, you would take that number, which is the molar mass of magnesium nitrate, and you would divide. So for example, 15 grams of magnesium nitrate divided by its molar mass gives you 0.101 moles of magnesium nitrate. To convert from moles to grams, you would do 0.25 moles, if that was the amount that you were given to start with, of magnesium nitrate times the molar mass of 148.33. Multiply those together and you would get your mass, which would be 37 grams. In most chemistry problems where we are doing conversions, we will do some kind of mole conversion somewhere in the problem. Avogadro's number is the number of particles that is equal to the quantity of a mole, and that number is 6.02 times 10 to the 23rd particles. So if we wanted to figure out how many particles were in this 0.101 mole sample of magnesium nitrate, you would multiply that by 6.02 times 10 to the 23rd, and you would get your number of molecules, because this is a molecule, and that would give you 6.08 times 10 to the 22nd. Let's move on to topic 1.2, which is mass spectra of elements. So we would also think of this as calculating an average atomic mass. So mass spectra tells us a couple of things about elemental samples. First of all, it is a graph that looks more or less like this. This is a sketch and not to scale. It gives us the number of isotopes, which in this case is 1, 2, 3 of magnesium. It tells us the abundance of isotopes. So magnesium 24, that's its isotope, would be 79%. Magnesium 25 is 10%. Magnesium 26 is 11%. By the way, these numbers represent the mass number of the atom, which is your number of protons plus your number of neutrons. So if we know that magnesium has an atomic number of 12, then we would know that this isotope has got 12 neutrons, this has 13, and this has 14. We can also tell the masses of each isotope, which is more or less equal to the mass number. So then that allows us to calculate the average atomic mass like this, which we would do by taking the mass and multiplying by its percent as a decimal. Then we would sum those numbers to get your average atomic mass. Remember, this is a weighted average. There is no division anywhere in here. This is calculated in the same way you would calculate your grade. I like to do topics 1.3 and 1.4 together because they're inherently related. This is the elemental composition of pure substances and the composition of mixtures. In Chem 1, you probably called this empirical molecular formulas. There are labs that are related to this. Those labs are typically either called gravimetric analysis or a formula of a hydrate. Got a cute little rhyme here: percent to mass, mass to moles, divide by small, multiply till whole. Here's an example with data that I got from chemteam.info. You can go check out several examples there. A 15.67 gram sample of a hydrate of magnesium carbonate is heated until a final constant mass of 7.58 grams. What is the formula of the hydrate? So we can calculate this. So we would take the final mass, which we would assume to be the anhydrous sample, which has no water, and we would divide by the molar mass of this, which is 84.31, to get the moles. We don't need to do the percent to mass here because we're not given percent data, we're given mass data. So then we would skip straight to mass to moles, which we just did. Then we would calculate the moles of water. Now to calculate the water, you would take your original starting sample, which is wet, and I need you to remember that wet minus dry equals water. So here's your wet sample, and then your final constant mass is your dry sample, and so then the difference would be your water. And then you would take that mass of water, divide by its molar mass, and get the moles of water. So now we've gotten our mass to moles. Now we need to divide by small. So between these two answers here, the 0.899 is the smallest, so we're going to set that ratio equal to 1, and then divide our other mole number by that same amount, and that's going to give us 5. And so here we have 5 waters for every 1 magnesium carbonate, and this is your formula. Now, a little bit about error here. If you did not heat your mass until constant, or if too much water remains or whatever, then your anhydrate, this one, the dry mass, is then too high, and that's going to skew your data accordingly. If you have an impurity present, then your anhydrous mass is too high. Finally, if you have a loss of a solid or incomplete precipitation or something like that, then your target mass, your anhydrous mass, is going to be too low. So, checking up on our progress, we are done with 1.1, 1.2, 1.3, and 1.4. Stay tuned as I keep going through the whole AP Chemistry curriculum.